Hello and welcome. Let's continue working on the physics engine. Last time we were working on the math library or the math class for all of our vector math. And now I want to start getting into creating the bodies that we're going to use to simulate our physics. So inside of our flat physics library, let's go ahead and add a new item. This is going to be I'm going to call it the body class, or in our case, the flat body. And this is going to be a sealed class, I'm pretty sure. And here we're just going to store all of the information that we need to simulate a rigid body. So this is a rigid body class, all right? And so let's go ahead. First of all, I'm going to start adding all the fields we need. We need to know their position in the world. We're going to need to know their velocity, and I'm going to call this the linear velocity because we're going to have different types of velocity. But so we want to know the orientation or its rotation, so I'm going to go ahead and write rotation. And then also I want the rotational velocity as well because it'll also have a velocity at which it rotates. And then we also want to store the physical properties of this body. So we want to store things like its mass, and right here we want to store the density. We want to store the restitution, or how bouncy it is. I also want to store its area, and then I want to have a Boolean that determines if it is static or not. Okay, and static, if something is static, it basically means it doesn't move and it can't get pushed. It's just completely fixed wherever it is. This will not react to physics. Other things will react to it, like they'll bounce off of it, but it will not move, and it'll be completely static in the scene. And so I think that's initially everything we want to store. Now, a flat body, I'm going to start off very simple. A flat body can either be a circle or it can be a rectangle or a cube or a box, I guess really what it is. So either a circle or a box. Those are the two things I'm going to allow. So I'm going to make an enumeration up here. And this is going to be a shape type. And it's either going to be a circle or it's going to be a box. Now, eventually, I'll probably have a polygon here as well. But let's just start with those to keep it simple. And I actually want to explicitly assign their values. So I want the circle to be 0 and the box to be 1. And then I also want to store... Okay, so if the body is a circle, it's going to have a radius. If the body is a box, then it's going to have a width and a height. And you notice I'm kind of storing these, regardless of what it is, I'm storing just every possible type we could store. Eventually, I think I'm going to go through and change that. So I'm going to have basically a shape class that will store all of this information in it. And it will store the right information depending on what type of shape it is. But for now, I'm going to keep this really simple. I'm just going to store it all inside the body. And then I'm going to record what kind of shape this is. So we'll have the shape type here as well. Okay, so that looks good. The only thing is, when you look at this, all of these values are going to change depending on what they're doing. But it looks like all of these things are just definitions of what this shape is. Like, this just defines what it is. And in fact, what I could do is actually make a class that just has like properties or something. And that might help with cache misses as well. Like the smaller I can keep this class, the better, because okay, well, I'm just gonna leave it like this for now, and I'm gonna look at maybe creating a separate class that will store all of this information that doesn't change, all this information that's always the same. And so instead of private, I want to make these all public. So let's change private to public. All right, and then I also want these to be read-only because they are not going to change. So I'm just going to add this to all of these. Okay, and actually shape type as well. And then every time I have public, this is my personal preference, every time I have a field that's public, I just make the beginning letter all capitals. I'll just go ahead and change these all real quick. Okay, that's looking great. And the more I look at this, I'm thinking, yeah, I want to pull this information out, and I want to make this a separate class, but I'm not going to do that quite yet. Now, the flat body itself, the constructor is going to be private, and I'll talk about why that is here in a second. I'm actually going to create the body with a separate function that will create the body based on what type you want to create. So if we want to create a circle, we'll have a function to create a circle. If we want to create a box, we'll have a function to create a box. But first of all I have to do is populate everything. So let me go ahead and just populate all of these fields. Okay, and then all we're going to do is just pass them on through to the values. So the position, the linear velocity, I'm going to just start with 0. And actually, all the rest of these here are going to be 0 just to start. And then let's just pass on the rest of these values. Okay, make some corrections here and here and here. Okay, perfect. So is static. Do I have that? Oh, this is a Boolean value, so let's change that. Okay, looks like we've got rid of all of the errors. Okay, perfect. So that will create or populate all of these fields. So the next thing we need to do is actually make some functions to create these rigid bodies. So we're going to have some static functions. They're going to turn Boolean because these functions can fail. All right, so I'm going to return a Boolean saying, was I able to actually create this this object? So we're going to call this create circle body. We're going to pass in the radius. Let's pass in a position. And maybe we don't even want to pass in a position. Maybe we want to populate position later on. Let me think about this for a second. I probably just want to create it here, or do I really want a position coming in? Okay, I'm going to leave the position there for now, but I don't think this doesn't look like the right place to put the position. Seems like we want to set the position another way. Okay, let's leave it there for now. I'll probably change that later. We need a density. We need is static. We need a restitution. See, area we can get. Radius we already have. Width, height, and shape type. Okay, I think that's it. And so all we need to do now is determine if the user has passed in a good radius and a good density. Now, really quick, we'll look up some good densities later, but I'm going to make a world class. And let's call this flat world. We're going to work on this later, but the flat world class, this is going to be where all of the work is going to happen. It's going to contain a list of all the bodies, and it's going to do all the physics work and everything like that. But for now, what I want this to contain is some values about the world. So I want a minimum body size, and I want it to be 1 centimeter cube or 1 centimeter squared. So this is going to be an area. So since we're doing everything in meters, 1 centimeter is 0.01, and I want to square that to be the area. Okay, and then the maximum, so the max body size is going to be 64 by 64, or an area of 64 by 64. And this is all in meters. So, and right now I'm just putting values in there just to get them in there. We can look at that later and maybe look for values that make more sense. But 64 meters is pretty large, and 1 centimeter is pretty large, pretty small. So I think this will work well. And then I also want, what do I want? A min density, and I want a max density. So I'm going to be using values for density that are grams per centimeter cubed. And the density of water, I think, is 1. Like if you have pure water, I think density is 1. And then if you have something that's lighter than or less dense than water, it floats. So things like wood usually float in water because they're less dense. So I want to use a value that's less dense than water to start. So 1 would be water. So I'm going to pick maybe 0.5 for our lowest density. And later on, I want to go and look up some actual density values, and we'll just put those in there. For now, we'll just pick 0.5, and then something that's really dense is, well, I don't know. Let's actually look up some values. So, density of wood. Let's just see what common densities of wood are. So in grams per centimeters cubed, we have 0.64, 0.69. This one, I'll say, so balsa wood is at 0.11. So maybe our min density is going to be like let's just do 0.2 for our min density. And then actually I want to look up common list of densities for solids. Okay, so these are all gas, liquid. We want solids. So ice is saying 0.920, which makes sense. So water at 4 degrees is 1, which is what we were kind of thinking. And then here's some list of solids. The Earth core is 13 grams per centimeter cubed. A black hole is 1 times 10 to the 15 grams per centimeter cubed. Okay, so we're not going to simulate anything that dense. Let's I'm thinking probably gold or platinum is kind of the max density we want to allow. Let's use platinum, 21.4. These ones are up at 22. Yeah, let's just use platinum. We're going to say 21.4 for our max density. So 21.4. All right, there we go. And so we'll work on this flat world later. I'm just going to populate it with these kind of these constants for our world. And so back here in our body, oh, actually, so we're going to create the circle. It's going to return false if it can't do it with the parameters they passed. But if it works, we want to pass out a flat body that is the result. So that'll be our body result. I also want to pass out a string that will have an error message. So if something didn't work, I want to pass out an error message right there and let the user know why it didn't work. So the body is going to be null for now, and the error message will be empty. Okay, so now the first thing I'm going to do is calculate the area. And for a circle, that's just pi times the radius squared. So let's do the radius times the radius times pi. And here's where we're going to check to see if that radius is good. So if the area is less than the world, the min body size, there we go. Then we want to turn false. And then if the area is greater than the max body size, then we also want to return false, saying, okay, you're trying to make a circle that's just too big, is what we're saying. And then we'll just make a simple string result here. So the error message will say, so circle radius, we'll just do the radius is too large, and max circle area is, and then we'll just put in here, oh, actually this is the min. So this is the minimum, I did that wrong, so is too small. The min circle area is, and we'll do the minimum body size, there we go. Now let's just copy this and bring it on over to the other one. And this will be too large, so this is, oh, I'm misspelling two there, so too small and too large. Max circle area is, and we'll just do the body. Okay, so I think I got that. Too large, max, perfect. All right, now the next thing I want to check is this density. So if the density is less than the world min density, let's do the error message with formatting and return false. And I can just actually copy this, and I'll go ahead and populate all of this information. Okay, so I think if we've gotten to this point, everything should be good. The only thing we want to check is the restitution. The restitution always needs to be a value between 0 and 1. And if they put something outside of 0 and 1, we're just going to clamp it. So inside our flat library, I'm going to make a clamping function. Let's go ahead and we're going to clamp floating point values. So here's the original value, here's our min, and here's our max. If the min is equal to the max, then there's really nothing to clamp. We're basically saying we want it to be this value, so we'll just return the min. So you can return min or max, there work either way. If the min is greater than the max, then we want to just throw a new exception that, hey, actually make this a new argument out of range exception. We'll just say that the min is greater than the max. If we get to this point, now we need to clamp to this min and max. So if the value is less than min, we'll return the min. If the value is greater than the max, let's return the max. Otherwise, we'll just return the value. All right, so there's our clamp function, nice and easy. Back here, the restitution, we want that to be clamped. So let's use our flat math. We'll clamp the restitution between 0 and 1. Okay, so that'll force the restitution to be a value between 0 and 1. So that'll work. Now, all we have to do is create the new body. We're just going to pass on through all of these values. And so let me do that real quick. Okay, and as you can see, I passed in everything. The only thing we're missing is the mass. And so let's figure out how to calculate the mass of a circle. And it's actually, when we're thinking about a circle, it's actually a cylinder, because if you turn a circle on its side, it's just going to be a cylinder with a depth or a height of 1. So we want the mass of a cylinder. Oh, and actually the mass of a cylinder would just be the area. It's going to be the area of the circle times the height times the, okay, yep, we don't need that. We know exactly how to calculate this. So it's the mass is going to be the area times the height, or the depth, I guess. That'll be the z value. So times the z, or depth, times the density. Well, let's just go ahead and write that out. So the area of a circle, we have that already, and we're going to multiply that by the depth, which is 1, and then times the density. Perfect. And this is a floating point value. We don't need to multiply by 1 because that just keeps everything the same. So let's just go ahead and remove that and multiply by the density. Okay, perfect. All right, I think we've got everything there. The what are we missing? Flat body. What looks like, so there's no argument given that corresponds to the required formal parameter shape type of, oh, did I not have a shape type up here? Looks like I'm missing something. Okay, so let's go ahead and look and see which one I'm missing. So I got density, I got the mass, restitution, area, static, oh, radius. So let's pass in the radius. There we go. Okay, now if we got to this point, everything is good and we can return true that it succeeded. Okay, so now we can create our circle body, and now let's create a box body as well. So let's copy this one, paste that over here. We're going to change the name of this. This is going to be a box. We're not going to have a radius. We're actually going to pass in a width and a height. The area is calculated by multiplying the width and the height together. And this is going to be box area. And actually, I don't need to specify that. I'm just going to say min area. And I'm going to say area is too small. Okay, that'll work there. Density should be the same. Restitution's the same. And then calculating the mass is the same, just area times the density. Instead of radius, we're going to pass in the width and the height. And we need to make sure that this is a box body. Oops, shape type box. Okay, perfect. Okay, that looks good. Yeah, perfect. Okay, so now we can create our boxes. Let's go back to our game class, or we can create our bodies. I'm going to get rid of this vector that we created last time. And then down here, we were drawing that vector, so I'm not going to draw any of that. And I'm just going to make a list of bodies. So here, let's make a private list of and we're going to call this the flat body. Or let's see, we're going to call this the body list. And all I want to do is create a bunch of random bodies and then draw them to the screen, just so we can see what they look like. And inside of our initialization code, let's create the new body list. I want a count. So the number, let's do body count. We'll just do 10 to start. And let's just do a for loop that lists through all 10 of these bodies and creates them in random positions. So these bodies can either be circles or they can be boxes. And that's going to be completely random. So what I'm going to do is make a type. And inside my flat library, I have a class called random helper. It just helps me get some random values really quickly. I want this to be between 0 and 2, meaning that the type of body can either be a 0 or a 1, which is either a circle or a box. If the type is equal to a, let's do a shape type circle, then it's going to do this. Otherwise, if the type is equal to a box, then it's going to do this. Otherwise, if it's not either of those, that means I'm probably doing something wrong right here. And so I'm just going to throw an exception just to make sure I catch all of those. And this will be unknown type. Here, I'm going to have the flat body just be null. Let's go ahead and calculate some random positions for the body here. And so we'll use the random helper again. We want a random single and a random single. The random positions need to be within what the camera can see. So I need to go up here to the camera class and I need to get the extents of the camera. And I have a function for that called getExtents. We're going to pass out, let's just do this. Let's get the left, the right. Let's just pass out all of these extents here. So let me grab that real quick. Okay, so now we know the extents of the camera. Let's tell it that for the X, we want a random position between the left and the right. And then for the Y, we want the bottom to the top. And actually, I want a little bit of padding in there. So let's make a padding value. And I'm going to make that 20. That's 20 meters of padding. I don't want the objects to be right on the edge. So I'm going to bring them in by this padding amount. So from the first one, we're going to add the padding. Then we're going to subtract the padding from this one. And then we'll subtract the padding from this one. Okay, perfect. So that looks good. We have the position. Let's go ahead and now create our circle body. The radius, I'm just going to make these all, let's just do all 3. So 3 meters is the radius. The position is going to be the X and the Y. So X and Y. The density, I'm just going to make them all just a random value of 2. Static, nope, we're going to make them all not static. Restitution, just again a random value. It doesn't really matter at this point because we're not physically creating, or we're not actually simulating them right now. And then let's go ahead and pass the body in and an error message. And then actually I want to check to see if this works. So if it didn't, I'm just going to throw a new exception. And then same thing for the box body. Let's copy this. So this will be a box. Now we need a width and a height, so I'll just make it 3 and 3. Position's the same. I think all of this is the same. Yeah, just the width and the height now. And then our list. Now we need to add this to the list. So did I create the list up here? Okay, so I did create the list. Let's add this to our list. And we'll just add the body to the list. Okay, perfect. Okay, so that looks good. We're creating 10 random bodies at random positions. And now all I want to do is go to the draw code and draw them. So we're going to loop through all of the bodies. Oh, and I don't need this line anymore, so let's get rid of that. Let's get the body at that index. If the body is, so if it's a circle, we want to do this. Otherwise, if it's a box, then we're going to do this. Okay. And let's use our shape batcher to actually draw this. So we're going to draw a circle. And we want to, we need to get the position. So let's make a flat vector that has the position. And actually, this is going to be a vector 2. So let's do a vector 2 position because monogame uses vector 2. So we'll have to do the conversion. So we'll use our flat converter, convert it to a vector 2, and we're going to get the body position. And I don't have access to the position. Let's go back to the world, or no, the body. We're just going to make a property here that will give me access to that position. Okay, so now we can get the position. Let's go back here. Okay, so we got the position. Let's go ahead and draw the circle. We need to pass in the position. And then what does it want? What's the radius? So this would be the body radius. Points, I'm just going to do some random value 26. I think that'll make it fairly smooth. And the color, we're just going to do white for now. And I'll probably change that here in a minute so we can differentiate between the different shapes. But let me now just draw the box. So we're going to draw a box at the position. And then I need a width and a height. So that'll be the body width and the body height, and then the color will just be white, and that should loop through all of our bodies and draw them. Let's run that and just see what happens. Oh, that did not work. Okay, what does it have? Null reference, objects not say. Oh, body was null. Okay, let's look at our body list, make sure. Oh, they're all showing up as null. Okay, that means we've got problems up here. Let's go ahead, go back to our creation. Okay, we set the body to null. I wonder if the shape type is not coming. Let's just run through this and see what happens here real quick. It's not giving me an error. In fact, if I go back to the body and I create, so I create the flat body here, which should be returned here. Okay, I'm going to put a breakpoint here in the creation code, and let's just see how they're being created. So the body's null. Okay, it's saying this is a box. It creates the box, and then we add the body to the list. But it's showing that it is null. Okay, so let's put a breakpoint at our creation code and just find out why it's showing. Let's go ahead and jump in here. Okay, so we got that. Oh, what is it? Oh, density is too large. Max density is 21.4. That's interesting. It's not giving me an... Why was it not giving me an error back in my code? Oh. Okay, so I'm totally doing this wrong. I checked to see if it succeeded, and if it succeeded, then I threw an exception. So I want to see if it failed. So I'm going to put a not here to see if it failed. That was okay. Those little mistakes like that, kind of fun to debug. Okay, so this should give me, so it's telling me that the density was out of bounds, I think is what happened. So what was my minimum and maximum density? Min density is 0.5. Let's run that and just see what it gives me for an error. Okay, so the error message is density is too large. Max density is 21.4. Okay, what am I passing for the density? Is it this one? That's the restitution. I'm passing 2, so that should not be too large. Let's go back to our flat body and just see. Density. Oh, and see, here's copying and pasting will get me every time. We want to do greater than the max body size here. And this is actually density, so the max density. So let me go over this and make sure I did this right. So the area is less than the min body size. Area is greater than the max body size. Density is less than the min density, and density is greater than max density. Okay, and I need to go down and change this as well. So this is the max density, and this needs to be greater than. So I'll do that. Okay, that looks good. Let's go ahead and run it and see if everything works. That looks right. Okay, so we have random circles and boxes at random positions. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. That looks perfect. Okay, so that seems to be working. A little bit longer episode, but we can now create bodies that we can start to simulate. I think next time I'm going to start working on the worlds class and maybe getting objects put into the simulator, or maybe I want to work on collision detection first before I work on the world. But anyway, a little bit longer episode, but we got our bodies, our flat, rigid bodies ready to go. Again, I'm probably going to change the way this is set up here, but it has all the information we need.